Good day, everybody! It's been a while since we last shared our beachcombing finds on YouTube, but we continue to visit ocean beaches and almost every time discover something interesting. Let's start with these leathery sacs that used to house fish embryos. Looking at the shape and size, these were likely produced by a skate, the type of fish closely related to sharks. The sharks and skates usually deposit such egg capsules at the bottom of the ocean. Those capsules are very well camouflaged to blend into the environment and stay unnoticed by predators. Due to their appearance resembling a pouch or a purse, they are sometimes called mermaid purses. Most of egg capsules contain one embryo, but the big skates can produce capsules up to 12 inches long with up to 7 eggs in it. It takes around 9 months for the embryo to develop into a young fish, which leaves the capsule through a small slit, keeping the capsule essentially intact. It seems that there is no special season when the adults prefer to produce the capsules. The spikes at the end are called horns, and their purpose is to anchor the capsule to the ocean bottom. The egg casings of a shark have curly tendrils that wrap around the algae, so the habitat defines the shape of the egg. The wavy structures on the sides of the capsule are called lateral keels. The presence or the absence of the keels may help to identify the species. To continue on the topic of cartilaginous fish, here's what looks like an upper jaw of a stingray. It doesn't have any teeth for some reason, but the tiny mineralized tiles covering cartilage are clearly visible. They are called tesserae, and their role is to reinforce the cartilaginous skeleton. You would not notice them in live fish because tesserae are covered with perichondrium, an additional layer of fibrous tissue. Some researchers call tesserae mechanical exoskeletons. Interestingly, due to mineralization, tesserae represent one of few body parts of cartilaginous fish that can be fossilized. Despite the small size of individual tesserae, they may provide useful information for paleontologists. Here's an example of such fossils from the sample collected in Eureka, Oklahoma. The sample included many shark teeth and dates back to the Permian period, approximately 270 million years ago. Marvelous. Now this one is a huge head of a bony fish with cool gills. Did you know that our jaws were developed from gills in the course of evolution, and our teeth used to be scales of our early ancestors? The plasticity of living creatures and their ability to adapt and evolve is truly astonishing. Here on planet Earth, they all contain pretty much the same building blocks, DNA and proteins. But look how different they can be, ranging from tiny microbes, jellyfish, crabs, to more complex creatures like birds, and us, humans. The shells of the calcareous marine worms, or serpulid tube worms, can be regularly spotted on the beaches of Central California. But have you ever seen one of these animals alive? Well, we recently observed a couple of them in a tide pool. I wonder how long these guys will stick around. They seem to be prolific because most of the shells of the turban snails from the tide pool had multiple tiny worms on them. See the red spot on the black turban snail? That's a branchial crown, mouth appendages used by the worms to grab the food particles and for gas exchange. They are essentially feather-like gills, brightly colored due to the presence of a carotenoid pigment. These structures can be swiftly retracted at the sign of danger. Here's a tube of another type, semi-transparent and quite fragile. It used to be a hiding place of a jointed tube worm. The tube was sticking above the surface of the muddy or sandy ocean bottom, providing protection to a tiny polycate worm who was likely a part of a colony. If a storm lifts the mud off the ocean floor, the tubes that resemble plastic straws can appear en masse on a nearby beach. They usually empty, and I wonder if only the top portion gets detached and animals survive and eventually repair their homes. Jointed tube worms can reach the length of 25 inches, by the way. Beach fleas are cute animals that love to munch on algae washed out on sandy beaches by waves. At first glance, the tide pool is static, but if you look carefully and patiently, you can actually notice a lot of movement. The limpet is carefully probing surroundings with tentacles, finding the way to fresh patches of algae on the rock. A purple sea urchin is extending its podia, or tube feet. This turban snail takes a ride on the top of a limpet. It's not for fun, but mostly to graze algae growing on the top of the limpet shell. A little bit of cleaning does not hurt, and the turban snail is probably not so heavy in the water. Hermit crabs crawl all over the place. These two look like they belong to genus Pagurus. Seagulls found a crab. Who is going to get it? It's not always finders keepers in nature. The anemones that inhabit tide pools of Point Lobos are quite beautiful, don't you agree? Cute little abalone from the same place. These shorebirds walking on the piles of dry algae are called turnstones. They are hard to notice. I bet they're searching for small crustaceans. When you see the sun nearing the horizon and disappearing behind the Earth curvature, you realize how fast things are moving in life. Nothing is stable in this universe. So, use your time wisely, enjoy your therapy sessions with Mother Nature, and please, 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 do not leave plastic on the beaches, okay? See ya!